What's up, dogs? Mr. Allen here. Let's do some math. Find the area of a regular decagon if it has a side length of 14 feet. So what do I know here? It's a regular polygon. It has 10 sides because it's a decagon, and each one of those sides is 14 feet. Perhaps the first thing we could do here is draw ourselves a decagon. So there's my decagon. It's honestly pretty difficult to draw, which is why I just went to the interwebs, copied and pasted one in for you. So I'm going to show you guys what I like to do when dealing with finding areas of regular polygons, especially when they have a whole lot of sides. First thing I'm going to do, let's jot down our formula. Area is equal to 1/2 multiplied by my apothem times my perimeter. Now I can actually find out my perimeter pretty easily right here. Since I have a side length of 14 feet and there's 10 sides, my perimeter is just going to be 140 feet, right? 14 times the 10 sides gives me that 140 feet. Okay, so we already got one thing. I need my apothem now. What I'm going to do is I'm going to draw just a portion of this decagon. What I'm going to do is draw these 3 sides here, here, and here larger so that we can work with it. So you can see, I drew 3 of the sides. Well, really, I only drew a portion of the other 2, but I'm mainly working with that bottom side right there, which we know is 14 feet. 14 feet, that's 14 feet right here as well. Since the diagram 1 is kind of difficult to draw, and 2, it gets kind of crowded in there, it can be nice to draw this open platform, the part that I'm really focusing on. So the next thing I'm going to do is I'm going to draw the center of this decagon here, which would be right here on my main diagram, and then draw some radii in there as I've already done. All right, so those are the radii of the circle that this regular polygon is inscribed in. We don't usually draw the circle, but those are radii that would go to the edge of the circle. Now my apothem is actually going to be a vertical line here going from the center to the edge of that decagon. So that's going to be this guy right here, or on this full diagram would be this one right here. And that's the length that I'm after right now, right? But there's a little more we need to do in order to get there, right? And it is perpendicular to that side there. Let's jot that down. So my 2 radii create a central angle of a circle. Well, that central angle could be found by doing 360 degrees in a circle divided by the number of sides, which would correspond to the number of central angles, in this case 10, and I'd get 36 degrees. That's my full central angle here. I just want a portion of that, and that apothem actually will bisect that angle, so it'll be 18 degrees right there. Now you can see where things can get kind of small and kind of clustered in that decagon. I'm going to leave that one alone for now and just work with my diagram that I drew to the side. So from here, I can actually find that my side length of 14 can help me out and get me 7 for that particular portion of this triangle. So I have an angle of that triangle is 18 degrees. I also have that right angle, and I have a 7 for one of the side lengths of that smaller triangle within that decagon. I need to figure out what my apothem is, which is this part right here. How can I do that if I have an angle and a side? If you said trig, you guessed it. Now I'm going to figure this out with some SOHCAHTOA action. Well, 18 degrees. Across from that is the 7. That is my opposite side. Next to it, whoop, that's my adjacent side there. So if I have my opposite and I want my adjacent, what are we going to be using here? Tangent. The part of SOHCAHTOA, tangent's what we're going to be using. Let's set up an equation with that. So I'm going to have tangent of my angle, which is 18 degrees, is equal to my opposite side, which is 7, divided by my adjacent side, which is conveniently my apothem and labeled A. Now I can solve for A. Be careful how we're going to do this, right? A is in the denominator, so I need to multiply both sides by A. All right. So now I have A times the tangent of 18 is equal to 7. I don't want to plug this into my calculator just yet because you know what? Yo-ro, right? You only round once. So I don't want to get tangent of 18, round it, and then do math. It's going to be far off. We don't want that. I want accuracy, baby. All right. So I'm going to divide by the tangent of 18. And over here, I'll divide by tangent of 18 as well. So in my calculator at this time, I'm going to do 7 divided by the tangent of 18. And let's make sure that we are in degree mode. That's going to give me what my apothem is. So when I plug that into my calculator, I get A is equal to 21.5437, so on and so forth, 8476, whole bunch of numbers, right? That is my apothem. So I will go ahead and jot that down right here. 21.5437, and I throw the ... there because I know I haven't rounded this value. I've left it in my calculator. I can find it in my calculator when I go to plug this all in. So now what I'm going to do is I'm going to take that formula, 1/2 apothem times perimeter, and plug in the calculations, the numbers that I've gotten. All right. So I'm going to have area equals 1/2. My apothem is going to be the 21.54378476, right? That's what's in the calculator, times my perimeter of 140. Okay. So what you can do in typing this into your calculator is I can type in the 1/2, then I can arrow up and select that. I'll highlight it and hit enter, okay, and then multiply by 140. So the calculator will copy it into that spot right there. So we plug all that in. I'm going to have 1,508 point. Now it's 0.649, but at this point in time, we are at our final answer, aren't we? So I'm going to go ahead and round this to 2 decimal places. It does not specify, so I'm going to pick 2 decimal places, 0.6, right? Although that 4 would be rounded up by that 9, we wouldn't then round again around that 6. We only round once, right? Yoro, it's not yort, you only round twice. It's you only round once, dog. So it's 1,508.06 feet squared. There's my units. We are done. That was a beast of a problem, but you're a beast of a mathematician. You know what I'm saying? That's what I'm talking about. All right. See you later.